Today we're going to solve inequalities algebraically. If I have an inequality, when I solve this, where it crosses the x-axis, it goes from positive to negative or negative to positive. So I'm going to look for every place it crosses the x-axis and break my equations into intervals and test those intervals to determine if it is positive or negative for my inequality. So for this first inequality, if I solve for x, I could subtract 3 from both sides, and I get 8 divided by 2, so x is less than 4, or my interval is negative infinity to 4. So if I just have a linear inequality, those are pretty easy to do. But what happens when you have a quadratic inequality? If you have a graph, you can see your intervals are below negative 4, between negative 4 and 2, and then above 2, because it crosses the x-axis at negative 4 and positive 2. It could touch, in this case it does cross though. So I would need to check each interval before, between, and after any zeros or solutions on my x-axis. And this inequality is positive, so it's above the x-axis when my values are below negative 4 for x, or if my x values are above 2. And when it's equal to 2 or equal to negative 4, it's equal to 0, but those points are included since I've got an equals there. So you can get them from a graph. So if you were taking an ACT, the fastest way to do this would be to graph it and look where the graph is positive, because I want it when it's greater than or equal to 0. So I've circled those two solutions. If this had been less than or equal to 0, I would circle everything that is below the x-axis. If you don't have a graph, you can also break this into intervals. So I would want to factor this. So I'm looking for something that multiplies to negative 8 and adds to 2, which was 4 and negative 2. So that factors into x plus 4 and x minus 2. This factor is 0 when x is negative 4. That factor is 0 when x is 2. So I would make a number line, and I would have my intervals broken for negative 4 and 2. So I'm going to test below negative 4, between negative 4 and 2, and above 2. So any point below negative 4 you can test. I picked negative 5, but you could pick negative 6, negative 10, it doesn't matter. Plugging in negative 5, I'll get 7 is greater than 0, which is true. So this interval is good. And then between negative 4 and 2, I picked 0. That's an easy one to test. So plug that in, and that's no. And then above this, I get a true statement. And it looks like this cut off. So this is for x is less than negative 4. It works. And so in interval notation, and that would have been or equal to. So that's going to be negative infinity to negative 4. And negative 4 is included because it is equal to 0. If I had greater than 0, I put a parenthesis there. This did not work. Or when x was greater than or equal to 2, those values worked. So that would be at 2, and 2 is included since it can be equal, and that's to infinity. Let's look at example 2. So on this one I have 3x squared minus 9x minus 12 is less than 0. So I want to go ahead and factor that. They have a 3 in common. This is now x squared minus 3x minus 4 is less than or equal to 0. I want it to multiply to -4 and add to -3. So that's going to be -4 and 1. So this factors into x minus 4, x plus 1, and that's multiplied by 3, and that's less than 0. And so my intervals I want to break into, I want a 4 and a -1. So let's go ahead and make our number line over here. And I'm going to put -1 here and 4 here. So I want to test a point that is smaller than -1, so maybe I'll pick -2. So I'm going to plug that in. So 3 times -2 squared minus 9 times -2 minus 12. And I want to see, is that less than 0? So is 18 less than 0? Okay, that's false. So it's no for this section. If I pick something between -1 and 4, so maybe test x equals 0. So that's going to be 0, 0, -12. So is -12 less than 0? And that is true. So my statement between -1 and 4 is true, but since it cannot be equal to 0, -1 and 4 make that 0. So I can't include those. So it's going to be -1 to 4 with parentheses. And then if I text above 4, maybe 5. So this will be 3 times 5 squared minus 9 times 5 minus 12. Is that less than 0? That's going to give me 18 when I plug that in. And 18 is not less than 0, so this is false. So it's no for this section. So my answer is -1 to 4. And up here you had to put those two parts together for your answer. I'm going to have you go ahead and try the next one. So you might want to pause the video so you can try it. I want to find my intervals, so I want to find when this is equal to 0. So it needs to multiply to -6 and add to -1. Those numbers are -3 and 2. So this factors to x minus 3, x plus 2, and I want that less than 0. So my intervals I'm going to need to put on are 3 and -2. That's going to break it up on my number line. So I have -2 here and 3 here. So let's test a value less than -2. So maybe test x equals -3. Plugging that in, I'll have -3 squared minus -3 minus 6. Is that less than 0? And when you simplify that, you'll get 6. Is 6 less than 0? No, that's not true. So that doesn't work for that section. So anything below -2 will not work. Let's pick something between -2 and 3. So maybe 0. Plugging 0 in, 0 squared minus 0 is 0 minus 6. So I'll get, is -6 less than 0? And that is true. And so between -2 and 3, this will be negative. And so my inequality is less than, it does not include the endpoints. So I'll have to put parentheses on that. On my last section, I'm going to test x equals 4. So that'll be 4 squared minus 4 minus 6. Is that less than 0? And that's 6. 6 is not less than 0, so it's no on this section. That is not a true statement. So my graph, this piece right here, this equation, is going to be negative between -2 and 3, but not including the endpoints. So that's my solution right there. What happens if there are no zeros? So if I were to do b squared minus 4ac here, I'll get b squared, so that's going to be -1 squared, which is 1, minus 4, times a, which is 1, times c, which is 1. I get a -3, so my discriminant is negative. So that means there are no x-intercepts, or no real zeros. So this graph then is going to either always be positive or always be negative. So let's just pick a value. So I'm going to plug in a value. To see if the graph is always positive or always negative. So on this graph, let's just type or plug in x equals 0. And you can plug in any x value you want. So if I plug in 0 here, that'll be 0 squared minus 0 plus 1. Is that greater than 0? So 1 is greater than 0. So this is true. And so this equation is always going to be positive. And I want to know, when is it positive? It's always positive, so the solution will be negative infinity to infinity for this. Everything works. If this, so this is extra, if I had had x squared minus x plus 1 is less than 0, when you plug in x equals 0, on that, you'd end up with 1 is less than 0, which is false. So it's never going to be negative. So if I had it less than 0, that's never going to happen. So in that case, there would be no solution. And that completes our notes.